So good morning, students. As we are studying about the WDM and the DWDM system, and our topic is the concept of cell phase modulation scheme. So the cell phase modulation. So we continue with this topic. So as the instantaneous frequency of a wave is the time derivative of its phase, then a time varying phase create time of varying frequency, the SPM can alter and broaden the frequency spectrum of the pulse. The spectral broadening caused by SPM produces dispersion-like effects which can limit the transmission rate in the some long-haul optical application, depending on the fiber type and its chromatic dispersion. For ultra-short pulses less than 1 picosecond, with the very high peak power, its effect can be very strong, generating a broad continuum of the wavelength. Although the SPM can simply be used for the wavelength and the frequency shifting, it has found the major application for the pulse compression within single mode fiber transmission. In this context, SPM effectively imposes a chirp or a positive frequency sweep on the pulse. This phenomenon combined with the group velocity dispersion occurring within the fiber allows optical pulses to be compressed by employing, for example, a pair of diffraction grating in which the longer wavelength light traveling at the front of the pulse follows a longer path length than the shorter wavelength light at the rear of the pulse. So here we can see the nonlinear optical effects due to the Kerr effect, that is a cross phase modulation. In this case, the multi-channel propagation, the index modulation induced by the Kerr effect modulated the channels, the other channels, and vice versa. So the cross-phase modulation is a similar effect to the SPM, excepting that the overlapping but distinguishable pulse processing, for example, different wavelengths or polarization are involved. In this case, variations in intensity of one pulse will modulate the refractive index of the another pulse. So we can see the cross phase modulation, that is XPM, in the case of the multi-channel propagation at various wavelength. The different channels modulate themselves via the SPM, but also each other via the fiber index modulation. The efficiency of the cross phase modulation, that is XPM, depends on the fiber chromatic dispersion, the channel spacing, and the channel power. So XPM induces a non-linear crosstalk in the channel. The nonlinear effect, optical effects are due to occur effect. The another effect is the FWM, that is called four-wave mixing. In the case of a multi-channel propagation and under the phase matching condition, the new frequencies are generated in the fiber, causing the crosstalk and the power depletion. So here we can see that it is a omega 1 K1, that is a omega 2 K2, that is omega 3 K3. So here is the time for the T2, here is the time for the T1. So we can see the three parameter, that is K1 here, K2 here, and K3 here. So here we can see the third order susceptibility tensor, that is a psi to the power 3. So it is a third order susceptibility tensor. Now the another explanation about the four-wave mixing, that is under specific phase and the wave vectors matching condition, four different waves will interact in the fiber in the non-linear way. The easiest way to obtain the FWM in the fiber is to propagate two waves at angular frequencies, that is omega 1 and omega 2 that will increase the new waves at the frequencies omega 3 and omega 4 such that the addition of omega 1 and omega 2 is equal to the omega 3 and omega 4. The phase matching condition. This phenomena is strongly dependent on the channel spacing and the chromatic dispersion. The generated waves may cause crosstalk if they are at the same wavelength as the incident channels. So some solution for the Kerr effect in the fibers are to decrease the field intensity by increasing the effective area. Example, by using the grade 652 or G655 leaf. Here leaf is stands for the large effective area fibers. In the case of the single channel transmission, the increase of the chromatic dispersion will automatically lower the SPM, but the problem is reported to the chromatic dispersion compensation. If the DCF is used, as the SPM may be high in such fibers. The another solution is in this case the multi-channel transmission. The increase of the channel spacing and the chromatic dispersion will decrease the cross phase of modulation effects. So thank you so much, students.